Hi everyone, welcome to today's webinar on Descriptive Statistics. My name is Neville. I'm from ITonlinelearning, and today I'll be guiding you through some concepts in descriptive stats that play a crucial role in data analysis. Okay, so for today's agenda, or the goal for today's webinar, is we are going to understand what descriptive stats are and why they matter, and also we are going to learn how to calculate and interpret them in a meaningful way. Before we actually get into the theory and the practical aspects of this webinar, I want you to imagine that you're a data analyst for a popular online store, okay? And the marketing team hands you a spreadsheet with hundreds of data points on sales, customer ratings, and product returns, and so on, okay? And they ask you, can you tell us what's going on with our customers? How would you start, right? So this is where descriptive stats come in. It helps us take that information or that data that they gave us and uncover meaningful insights that we can understand, communicate, and act upon. Okay, so descriptive stats are essentially the building blocks of data analysis, and without them, data is just a collection of numbers. But with them, we can actually begin answering questions like what is or what are the average and typical customer ratings, and how spread out are those ratings, right? So if the data we have consists of customer ratings from between 1 and 5, right, what is the average customer experience like? Because they would put that down, they would either give it a 1, 2, 3, 4, 5, right? So we want to know the majority of our customers, how are they feeling, okay? And in today's webinar, that is the question that we will be answering, okay? So by using descriptive stats, we can see that descriptive stats help turn these questions into measurable insights. There are three types of descriptive stats, right? You can think of these like three buckets, okay? So the first one is measures of central tendency. So these describe the center of our data's distribution, right? So it helps us understand the typical or central values of each data set, okay? So the first one we have is the mean or the average, right? And this is the average of all our data points. So the mean rating would provide an overall view of how customers feel about the product. So for instance, if the mean rating is 4.2, it indicates that customers generally rate the products positively, whereas if the average rating was like 2.3, and that raises concerns, right? That means that they are dissatisfied with the products. The next one we have is the median. So the median is the middle value when our data is ordered. And to give you an example of that, our data needs to be in order, right? So either ascending or in descending order, because the median finds the middle value. As you can see from this, it finds the middle value. Now there's two ways to calculate this, okay? If we have an odd number of values in our data set, it's easy to find the middle value. But if we have an even number in our data set, we essentially find the two middle values, we add them together, and we divide by 2, okay? And that will give us 28. So the next one is the mode. Now the mode is essentially what number or what rating, what value repeats the most, so it's frequency, okay? So our next bucket, which is measures of dispersion, right? So this indicates the spread of the data, and these metrics show us how much variation exists around the central values, okay? And this helps identify inconsistencies or instability in like customer behaviors. Okay, so we have the range, right? So the range is just the difference between the highest and lowest values. The variance is the average of squared differences from the mean, and the standard deviation is just the square root of our variance, okay? If the standard deviation is high, it means that customer satisfaction varies significantly, right? So customers love the products while others do not. That's if we have a big variation, right? So in terms of our rating, if our standard deviation for our rating was like a 2.5, that's a wide standard deviation. And if our standard deviation was much smaller, like maybe a 1.2, then there's a slight difference in variation between how our customers feel. So our last bucket is measures of shape, and this just shows us basically skewness or symmetry, right? So now there are three main types that our data could fall into. One being symmetric, okay, where all the mean, median, and mode would conform towards the middle, and that this gives us a symmetric shape, a symmetric bell curve, okay? The next two that we have is right or positive skewed. So if we have a right or positive skewed data set, that means that in terms of our customer ratings, going from 1, 2, 3, 4, and 5, this shows that most customers chose to give a rating around 1 and 2. This means that they have a negative experience or view towards the product or service, okay? And if it's left or negative skewed, this shows that most customers have a very high satisfaction with the products, okay? Okay, so that's it for the slides. So this data set, just briefly go through it. So as we can see, we have 3 columns, and in these 3 columns, we have customer ratings, monthly sales for 12 months, and we have how many days it took for these products to be returned, okay? This data set will be included in the description below if you would like to follow along. So I will be using VS Code, but let's first create a folder. Let's just call it this webinar. And let's actually open up VS Code. Okay, let's just wait for this to load. Yeah, awesome. Yep. Okay, now that we have our VS Code open, we need a Jupyter notebook. So let's just name this DS for Descriptive Stats, and we need a Jupyter notebook. So when we start in our Jupyter notebook, we need a few libraries, right? And when you're doing a project or you need to answer a question using Python for data analysis, we need to import a few libraries. So a few of the libraries we will import will typically be your bread and butter libraries. These are the libraries that you will use, if not all the time, majority of the time, okay? So we need pandas. Okay. I will explain what all of these libraries do, like what are their specific purposes. But that's what. And we want SciPy, we want the stats module. I'm going to input this as skill. Okay. So essentially these libraries, if you don't know what these libraries are, I'll briefly explain them. So pandas is responsible for our file structure and data frames. NumPy is responsible for your calculations, just numerical calculations. Matplot is responsible for our basic visualizations. Seaborn builds on Matplot and helps us create a more in-depth graph or chart. And SciPy, we are importing the stats modules specifically from this library because we need this scientific calculation, right? So that's what this one is for. Okay, so let's run this. So next, what we need to do is, once we have our necessary libraries, we need to import our data sets, okay? So let's create a variable. Okay, let's get our path. Now, once we actually have our data sets imported into a variable, or stored in a variable, excuse me, we need to make sure that there are no errors, right? So let's just view the first few columns. Okay, so this works. Let's actually also see the bottom of our data set. So dot head, this function will show us first 5 rows. By default, it shows us the first 5 rows, but we can obviously limit this to 1 row. If we want to see 10 rows, okay, we just specify 10. And yeah, but by default, okay, it's 5. Okay, and also dot tail will do the exact same thing, but from the bottom. Okay. Yep, this is correct, because we know that our monthly sales, we only have 12 rows. So if we put here, for example, 13, yep. So this is correct. Okay. Okay. So next we need, so we have our column names, because our column names will be important for all our calculations just now. But to actually get them, just so that we don't make any mistakes, we can say, I'm going to actually change this to data. Okay, so let's actually get our columns. Don't forget your brackets, guys. Data is not defined. Okay, so when you're using Jupyter notebooks, okay, something to always remember. Let me just move myself out the way. When you're using Jupyter notebooks, something to always remember is that if you change a cell, for example, we changed our cell from DF to data, you always need to rerun your cell. Okay, so let's just run all. Okay, and as you can see, this ran fine. So again, I'll show you. Let's just clear this output. We actually don't need these. Okay, so we know that this is giving us the correct output. But if we change this to DF and we run this, okay, now we have a line under here saying that data is not defined. Okay, so as we can see, it says data is not defined. So this is the program's way of telling us that we don't have a variable called data. Okay, so let's make sure to just rerun your cells once you do change information. Okay, so next we need, so remember the question was, what is a typical customer rating and is there much variation? We need to use our measures of central tendencies, okay? And that is mean, median, and mode. We need to find out what is the mean, median, mode, variance, range, and standard deviation, and also what is the skew of our data, okay? So remember, this is the question that we need to solve for. Okay, so let's get a few variables. We'll name this mean rating, and this will be equal to our data, and we need the customers column. Okay, that's one. Next, we need the median. And we need the mode. Okay, let's run our cells. Mode rating is equal to data customer ratings dot mode. Invalid syntax. Oh, okay. Because we don't have the actual mode there. Okay, awesome. Okay, so next we actually want to get our standard deviation. Just name this standard deviation is equal to data. We can actually include this up here. Okay. Another trick to know that your code cell was successful is if it shows a number in these square brackets. That's how you know that the code block that you just ran was successful. Okay. If there's an error, it'll throw an error. So let's see if this, yeah. So if there's an error, it will give you an error. But if it's successful, it won't give you any outputs unless you explicitly state that you want something printed out. Okay. Let's run this again. Okay. And we also want calculate the skewness value. Okay. So let's get our customers rating column on the time. Okay. So now we can actually start to get our variance. Name this and we want our, nobody already calculated our standard deviation. Okay, so now that we have, this is everything that we need, our mean, median, mode, the standard deviation, variance, and the skewness values. Okay, so let's actually print out these values to see what we're working with. I'll be using an if string, and I want to see how the skewness. Okay, so what's happening here in this line, in this block of code, is we're essentially printing out the value that is being calculated here. Okay, and this .2f is just saying that whatever value this is, we only want it to 2 decimal places. Okay, so let's comment this out and let's actually just get the value for skewness. Most likely be a long number, yeah. So this is the actual value of skewness, but we don't want such a long value. All these other numbers towards the end are unnecessary. So to get a workaround for that there is we use, we say that we only want 2 decimal places and we want it to be a floating point number. Okay. So let's also get our, we want standard deviation and variance. So let's get the variance first. Let's get our standard deviation. Okay, so we can see that our variance is 1.36 and our standard deviation is 1.16. So remember in the beginning of the webinar, I said that if our standard deviation is something like 2 or 3, that means that there's a wide range of variation, okay, between customers and how they feel about the products. Okay, now we can actually start to, we can start building on our visualization. So we'll be using a histogram, but first we need a figure size. Oops. We want, yep, we want to use a size of maybe 6 by 6. Okay. We want a histogram. So hist plus is just the terminology for histogram. And we want to actually include our column, which is customers rating. We want our bell curve to be true. Okay, so we know that we want to see our mean, median, and mode, standard deviation, and skewness. Okay. So let's actually get our lines. Or let's actually get the basic. Let's get our title. Let's first get our basic charts up and running, and then from there we can add to it. Okay, so let's get our x-axis. On our x-axis, we want the ratings. Let's just copy this. Okay, and we want one more. We want our y-axis. We want the frequency of the counts. Just name it fig. Okay. So let's actually get the legend. Okay. So this is our basic charts. No labels. Okay, don't worry about this. This is just saying that because we've added our legend here, but we have nothing to show in our legend. That's why it's giving us this error, but we will add to this. Okay, so this is our basic chart, and we can see that a rating of 4. So we can see that out of all our customers, the average rating, or sorry, not the average rating, the most frequent rating is 4. Okay, we can see that just by this chart. But now, what we can also take away from the chart is we can see that our chart is not symmetrical. It's actually skewed to the left, meaning most of our data is towards our right side, with the tail end being on the left side of our graph. Okay, so this means that it's skewed to the left. Okay, so negatively skewed. And this is telling us that most of our customers are satisfied with the products, with a very few of the customers actually bringing this chart down a bit, which means our which means our average will most likely not be 4. Okay, because our median, mode, and average will always be the same if our graph is symmetrical. Okay. Okay, so we can see that our mean is actually 3.58, which makes sense because our data is not symmetrical. So this makes sense. Okay, let's continue to add to this. We want to see our median. Okay, let's can make this a different color. But let's first see. Okay, so we can see it. Let's actually make this a different color. Let's make this red. So we can see that the median, being the middle of our data set, is 4. Okay, and we can see where it falls. Okay, so most likely that is and will overlap with our mode. Let's make this green. Let's go solid line, and so this is median and this is our mode. Okay, so we can see that our median and our mode overlap, which makes sense because, again, our data is not symmetrical. Okay. Next, we actually want our standard deviation. Now, the standard deviation will basically tell us how far away from the average is the typical range of ratings. Okay, so let's copy this one more time. we want or standard deviation. Okay, we want the variable. Let's give it a different color. Line style is okay. For the label, we'll give it, we'll just call it plus positive standard deviation. And then this would be this calculation. Okay, so let's actually see what this looks like. So we can see that one standard deviation to the right of our mean will give us 4.74. Okay, so we know that on the higher end, that the ratings will typically go between our average, which is 3.58, and one standard deviation higher, which is 4.72. So let's actually get the lower bound level of our standard deviation, or one standard deviation before. This will just be negative. Okay, so what this is telling us is that this is the range. So from 2.4, so from a rating of 2.42 to a rating of 4.74 is where majority of our ratings will fall between, with a mean or average rating being around 3.58. So this is how, and we can actually check this. Let's go into Excel, and we can actually view these. We can actually verify that these numbers are correct. So in Excel, you have a tool called the data analysis tool. Okay, so if we just pull this up, we want the descriptive stats. Yep. We want our ratings, and we want summary statistics. Okay, so let's pull up VS Code one time. Okay, so we can actually verify these numbers. So our mean is 3.58, and Excel is telling us that the mean is also 3.58. Let's make this a bit bigger. Okay, so we know that the mean is 3.58, the median is 4, and the mode is 4. That's correct. Our standard deviation is 1.16. We did calculate this. Yep, our standard deviation is 1.16. Our variance is 1.357, but they rounded up, so 1.36, correct. And our skewness is negative 0.5. So yeah, so our calculations are correct, and this does verify that a negative skewness value represents a negatively skewed bell curve, okay, which tells us that majority of our customer ratings will fall in an upper bound between 3 and 5, okay. To be exact, it will fall between 2.4 and 4.7. Okay, so thank you guys for viewing today's webinar. So if you enjoyed today's webinar and you'd like to learn more about data analysis, there will be a link in the description where you can view our courses, which are very well designed. You will learn so much from these courses. They are very comprehensive. So again, thank you. I really hope you enjoyed today's webinar, and please don't forget to like, subscribe to join our channel for more webinars on data analysis and much more.